Today we're going to talk about triangles on the coordinate plane. And one of the keys to this is drawing a good picture. I think if you can draw a good picture of the triangle, this will make these types of problems a lot more user-friendly, shall we say. A lot easier to understand. And the first one says, find the values of the 6 trigonometric functions for an angle theta in standard position if a point with the coordinate 3, -4 lies on its terminal side. Lots of words there with some vocabulary in there. And first of all, let me refer back to initial side and terminal side. So the first thing that I'm going to do is I'm going to draw in a mini coordinate plane. And what we know with standard position is that the vertex is going to be at the origin, and our initial side is going to be along the positive x-axis. I'm trying to darken that in a little bit. I should have changed colors, but oh well. Here is our initial side. And what this problem says is it says that the terminal side is going to be at the point 3, 4. Sorry, 3, -4. So over 3 down 4, so to speak. And when we draw a triangle, so what that's saying here is that our terminal side is going to be here, going to go to there. So we would measure it, at least I would, measure it that way, with the direction. But what we're looking at here is we're looking more specifically at the triangle. So I probably shouldn't have even drawn that direction there. But with the triangle, it always connects back to the x-axis. This is the x-axis. So we're going to make our right angle there. I'm sorry, the board's just a teeny bit disoriented. But remember this point right here. How did I get that point? Well, I went over 3 spaces to the right, and then went down 4. So this point here is 3, -4. In other words, we can label the sides of the triangle with those values. On the initial side of the triangle, we went over 3 spaces. And then the height of the triangle, so to speak, it's upside down, but we went down 4. So the base of the triangle is 3. The height of the triangle in this case, it's -4. It's only negative because it went downward. And what we need to know is what's the length of the hypotenuse in this triangle? And some of you remember from geometry, your special right triangles. But if you don't remember them, then we're going to use the Pythagorean theorem.
Yes, you can do it that way.
You maybe can.
Yes.
If we want to know what the side length is, and actually it's the hypotenuse, if we want to know what it is, we're going to say 3 squared plus -4 squared equals, I'll call it c squared because it's the hypotenuse. And when we do that, we get 9 plus 16, c squared. And 9 plus 16 is 25 equals c squared. And to solve this, we need to take the square root of both sides. We end up with c equals 5. Now, some of you did not need to do that work because you already knew that the hypotenuse was 5. I'm fine with that. If you look at my notes, you will see that I don't have it written down either. But once we know that, now we can fill in all of these trigonometric values. There's a little bit new stuff here, but it'll be okay. We'll figure it out. As we label, this is theta. And I should have labeled that a little bit earlier, but there's where theta is in standard position. And because theta is there, when we go across from theta, that 4 is going to be the opposite. Across from the right angle is the hypotenuse, which means that the side that has the length of 3 is the adjacent. And once again, at the very top of your paper, you maybe want to write. So, Katoa. Sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. Tangent is the opposite divided by the adjacent. So when we go ahead and fill in sine, cosine, and tangent, well, sine is opposite divided by the hypotenuse. -4/5. Cosine is the adjacent divided by the hypotenuse. 3/5. Tangent is defined as opposite divided by the adjacent. Opposite divided by the adjacent. And then we have some new words over here. We kind of got a little bit ahead of ourselves, and I didn't realize it until just now. But it'll be okay because we're going to spend the rest of the week on it, so we'll consider it an introduction today. CSC theta. CSC stands for cosecant. It is the reciprocal of sine. So if sine is -4/5, the reciprocal of -4/5 is -5/4. SEC, secant of theta. Secant is the reciprocal of cosine. When we take the reciprocal of 3/5, we end up with 5/3. And tangent has a reciprocal of cotangent, abbreviated COT. Cotangent of theta. Cotangent is the reciprocal of tangent, so this becomes -3/4. Again, on these problems, we need to get the triangle drawn correctly. If we can get the triangle drawn, then hopefully, in the scheme of things, coming up with the different functions will be much easier than it could be without the picture. Let's try another. It says find the values of the 6 trigonometric functions for angle theta and standard position if a point with the coordinate -3, 1 lies on the terminal side. I'm not going to make my picture quite so precise this time. But once again, standard position has the vertex at the origin. Our initial side is along the positive x-axis. And the question then becomes what quadrant is the square root of -3, 1 in? Well, the square root of -3, 1 is in the second quadrant. We go left, -√3, and then we're going to go up 1. So our triangle, which always connects back to the x-axis, and sorry, board's still a little bit disoriented over here, always connects back to the x-axis. Here's the point. It's -√3, 1 is here, which means when we actually label our lengths of our sides of the triangle, we went the square root of 3 and actually negative the square root of 3 because we went left the square root of 3, and then we went up 1. And this one not maybe quite so clear in terms of special right triangles. Maybe there are some of you who can figure out the hypotenuse, but if you can't, then use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Sometimes I'd like to say that it's side squared plus side squared equals hypotenuse squared. Again, I'll call the hypotenuse c. Negative squared becomes positive. square root of 3 times square root of 3, if you need to write it, is square root of 3 times square root of 3. Well, there's 2 of the same. Take out 1. Square root of 3 squared is simply 3. It's the square root of 9. What's the square root of 9? If you need more detail. You could even type that in the calculator, but make sure you have parentheses around it. Plus 1 squared, which is 1, equals c squared. And 3 plus 1 is 4, oh dear, equals c squared. And then we can take the square root of both sides. So c equals 2. I am going to leave the distance as positive here because it is a distance. You can fill that in. Once again, just like that last problem, I forgot to label the angle here. That's the angle that we want to deal with. And once we identify that fact, and now that we know every part of our triangle, we can fill in sine, cosine, and tangent, and therefore cosecant, secant, and cotangent. Across from the angle is the opposite. Across from the right angle is the hypotenuse, which means that the negative square root of 3 is the adjacent. And now that we know those values, we can fill in sine, cosine, and tangent. And sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. Tangent is opposite divided by adjacent. 1 over negative square root of 3. But just a reminder that we do not like having a radical in the denominator, so we need to rationalize. When we rationalize, we're going to multiply by radical 3 over radical 3. Fancy form of 1. When we do multiply it, I'm going to have an extra step in here, but 1 times radical 3 is radical 3. And radical 3 times radical 3 is radical 9. We don't really need that negative on the bottom. We can write it out here in front. We can also write it out on the top of our fraction. But what does the square root of 9 equal? It equals 3. So 1 divided by negative radical 3 is the same thing as negative radical 3 over 3. What we just did is we rationalized the denominator. We don't want a radical in the denominator. That's sine, cosine, and tangent. Once again, cosecant is the reciprocal of sine. So if sine is 1/2, cosecant is 2 over 1. Secant, theta, is the reciprocal of cosine. So this is going to be 2 over the square root of 3. Don't forget the negative. And once again, now we have this radical in the denominator. It's going to be a really tight squeeze for me to get this in. But the process is still going to be the same. We're going to multiply by radical 3 here. We're going to multiply by radical 3 there. The fancy form of 1, we're multiplying by. And when we do, without showing my work here, I'm going to get negative 2 radical 3 over 3. Just a reminder, square root of 3 times square root of 3 is square root of 9. And what does square root of 9 equal? 3. That's where I got that. I can show more work in a little bit if you need help. Finally, the cotangent is reciprocal of tangent. And if we keep our life simple, remember what we originally got for tangent. We originally had 1 over negative the square root of 3. If we take the reciprocal of that, then we get negative square root of 3 over 1, or just negative square root of 3. If you didn't see that, our other value here that we found for tangent, it was negative the square root of 3 over 3. So we would have to flip that because it's reciprocal. So it would be 3 over negative radical 3. And then we rationalize. We multiply by radical 3 here, and we multiply by radical 3 here. So we end up with 3 radical 3 over the square root of 9. Don't forget the negative. Square root of 9 is 3. And then lastly, there's a 3 on top, there's a 3 on bottom. There's where that negative radical 3 comes with a little bit more work. So again, to summarize, if we can draw the picture by the side lengths of the triangle, then we should be able to figure out what sine, cosine, and tangent are, and consequently, we can figure out then what our reciprocal functions are. So when we look at problem number 3, same kind of thing, a little bit different information given. And this one says, suppose theta is an angle in standard position. So we're still going to have to draw our picture. This time what we're given, it says, if tangent of theta is square root of 3. Nice. One less function we have to find. Tangent of theta is square root of 3. And sine of theta is less than 0. What does sine of theta less than 0 mean? What does less than 0 mean? I'll be less specific. It means negative. So this value here, this means that sine is negative. And we're going to have to draw our picture in a moment. So this is going to go back to some previous notes. And what we talked about is all students take calculus. That mnemonic to help us remember that all functions, in fact, all 6 of these functions are positive in the first quadrant. Sine is positive in the second quadrant. Cosine, nope, tangent is positive in the third quadrant. Take for T for tangent, and C is the cosine. Tangent over here, given information, happens to be positive. And because tangent is positive, then we need to be working in the third quadrant here. Here's our initial. Here's our tangent. And again, board a little bit disoriented, but I'm pretty good on this. The triangle always connects back to the x-axis. We're given the fact that tangent of theta is the square root of 3, which is the square root of 3 over 1. Because it's opposite divided by adjacent. So let's label our triangle before we get going too far. Our angle is here, and across from that is the opposite. Across from our right angle is the hypotenuse, which means that our other side here is the adjacent. And the information that we know in this particular problem is we know opposite divided by adjacent. So we know the square root of 3 over 1. You may know what the length of the other side is this time, but not to overlook it in case you don't. If we do not know what the hypotenuse is, then we use a Pythagorean theorem. 1 squared plus the square root of 3 squared. Again, I'll use C for the length of the hypotenuse. 1 squared is 1. Square root of 3 squared is 3. Square root of 3 times square root of 3, square root of 9. 2 are the same to take out 1. And over here, C squared. 1 plus 3 is 4 equals C squared. And take the square root of 4. And just like the previous problem, we get C equals 2. We were given a little bit different information, but it ended up to kind of sort of be the same. And I do mean kind of sort of. Now that we know our lengths, we can go ahead and figure out our values I do need to change one thing in this triangle, and I'm not really changing, so you don't have to erase something. But as we take a look here on this triangle, this point here is going to be -1 the square root of 3. Because we went left 1, and then we went down the square root of 3. So I'm going to put the negative in there to indicate that correct point. And if we have the signs appropriately on our triangle, I know it's not a distance of -1, it's just that we went left 1, then that's going to allow us to put the proper signs in on our values over here for sine, cosine, tangent, along with the cosecant, secant, and cotangent. Sine of theta is the opposite divided by the hypotenuse. And at this point in time, you're saying, well, Miss Danhoff, we changed the 1 to negative. Why didn't we change the square root of 3 to negative? Because we went left 1, and we went down the square root of 3. So this is going to be the square root of 3 that's negative divided by 2. Now that I have all the signs correct, we'll get the rest of them fine. Cosine is the adjacent divided by hypotenuse, so this is going to be -1/2. We already have the tangent. Once again for cosecant. Cosecant is going to be the reciprocal of sine, so we're going to flip that fraction, and it's going to be 2 over radical 3. Without showing all of my work, I do want to point out that to rationalize this, to get rid of the radical in the denominator, we multiply both sides by we multiply the top by radical 3 and the bottom by radical 3. And we end up with -2 radical 3 over 3. I know I didn't show my work. I'll be glad to help you in a couple minutes if you need help with that. Secant of theta is going to be the reciprocal of -1/2, which is -2. And cotangent, which is the reciprocal of tangent, is going to be 1 over the square root of 3, and I can show my work a little bit better here on this part. We're going to multiply, again, by a fancy form of 1, by radical 3 over radical 3. When we multiply fractions, we multiply the tops together, we multiply the bottoms together. So 1 times radical 3 is radical 3. I want radical 3. Radical 3 times radical 3 is square root of 9. What does the square root of 9 equal? It equals 3. So square root of 3 over 3 there is what our cotangent equals.